use other algorithms. The one I've listed here is called the Fourier domain Monte Carlo estimation for the error. And if you had enough time to finish the thing, we could have even tried to produce TOAs that were IPTA ready, because the IPTA defines a standard, which means you have to have certain amounts of information along with the TOA. The TOA is just a timestamp, and then you need the frequency, you need the system it comes from to locate the thing on the geoid and do all the translation. But you also need other information about the receiver, the front end, the back end, and a whole bunch of other flags. That's what we call these extra key value pairs. But those three commands, or either the first and the last, or actually, no, sorry, one of those three commands is what you would use to produce TOAs for timing. We'll come to TOAs and TIM files and PAR files in the next session, which is the Tempo 2 session. But right now, I just want to quickly take you through Psrchive Python bindings. So this is going to be a bit easier because it's after lunch, so I'm not going to make people do a lot of work. I'll quickly read through basically a set of slides which were presented last year, and I've again mildly modified them. How do I? Okay. Where was it again? Home. Oh. Sorry. All right. No worries. Go. Hey. So, again, this is just, I mentioned that you can compile Psrchive so that you can import it as a Python package, which is basically what these fancy jargon terms mean, that you can access the C or C++ functions, that as in the functions written in C++ can be called directly from within Psrchive, from within Python, instead of if some Pythonistas are sitting around, you know that there is an alternative way of doing this, which is you can actually execute programs from within Python by using certain packages, but that comes with an overhead, and you can avoid that overhead and use the classes and the functions directly from within Python. Those are the Python bindings. Essentially, this is a set of wrapper code which allows you to access, for the specific case of Psrchive, it's just a subset of many of the functions that exist in the Python in the Psrchive code base. So this first description is not completely correct, but it's correct in the sense that it's not the same thing as, so there is no import Psrchive and then psrchive.pam. There's no such function called pam. Instead, you can read in an archive, and then you can do fancy manipulation within Python. You can use all of the power of Python that is available to you. You can do whatever you want with these arrays. In certain cases, you can also import other objects, but not. So the thing to remember is it's not that I stopped using the shell and the Unix environment and I switched entirely to Python. You can do it, but you'll have to write certain functions to replace the functionality of the programs. So that's a mild distinction to remember when you're going from one to the other. This is the disclaimer. This talk has been given before. I'm borrowing very, very heavily. So why do we want to do this? Because we all love Python. More importantly, it's sometimes much more useful to have a simple high-level language like Python, and I'll come to why it's like Python, that's important, which you can use to very quickly inspect your data, and as you get into larger and larger volumes, you don't always want to sit and write a new C function to probe, just make a quick look or a quick analysis of is the data fine, is everything being recorded in the right places. So if you know Python, you know it's easy to do these things. Just plug it in and get on with what you want to do. Sometimes shell scripts can be incredibly annoying and difficult to, mainly for bookkeeping. So keeping track of what you're doing with your data. If you're doing it with shell scripts, you have to create so many variables, or you have to create a log file. And if shell scripting is what you've been using so far, then I would recommend testing out Python, because the bookkeeping part becomes a lot more easier. You have all the power of the Python packages to use. You don't have to manually write slow functions, which the shell has to read line by line and then process at a phenomenally slow rate. Plus, it's portable, because shell scripts, like it or not, are not that great at portability, unless you really are a whiz. But of course, the big caveat in all of this is it's not straightforward to do a pat inside the Python bindings. You can do it, but it's not. You'll have to write some convenience functions, and you can do all of that, but it takes a little bit more effort than shell scripting. Okay, so what's at the heart of this? You can ignore most of the text on this slide. This simplified wrapper and interface generator is one of the many ways in which you can produce wrapper code for C and C++. In fact, I think Swig, correct me if I'm wrong, Swig can do other languages? Yes. So Swig can do other languages. So if you have Fortran code, which is ancient, and you want to somehow find a way to use it, you can pass it through Swig. All it does is it automatically generates a bunch of wrapper code around your core old language function and lets you access those functions from within Python. And there's a very interesting project there, which is Swig can let you generate wrappers for languages other than Python. If anyone here is interested in languages like Julia, for instance, that's a project to try if you are young and brave. I'm not. Okay, and you can find more information at swig.org. Okay, so there's nothing special that you need to do to get Python bindings to work with. Yeah, typically.
Shared libraries.
Yes, yeah. So the only thing you have to do is you follow the there's a set of standard commands for compiling Psrchive. You follow that, but at the very first stage, you have to make a configure file, which is done by calling /configure and then supplying a bunch of options. One of the most critical option there is you have to say -- enable -shared. If you don't do that, Python bindings are not compiled, and you can't do import Psrchive. So you have to remember to do that at compile time, and then you're set. If you want to try, okay. So sorry, before I go there, there are of course standard some dependencies. You need the development packages for Python pre-installed on the system you're working with. You need Swig, you need NumPy, and you can have these other packages which are not dependencies, but they're useful, of course. If you want to try out Python 3, this is again unknown territory for most people. If you want to try out Python 3, the thing you can do is you can say, you can look at the config file, and there's a particular handle to supply the Python path. And there you say, instead of Python 2.7, you say Python 3, and it compiles. I have tested this. I have not tested the compiled code. Okay, so quickly back to the Psrchive data object, which is 3 dimensions, 4 dimensions, however you want to treat it. So again, a quick revision. profiles are intensity as a function of rotational phase. An integration is a set of pulse profiles which has been recorded across a given frequency. So, or in this case, it could also be polarization. And an archive is a compilation of such integrations. There was a little bit of confusion when I put this up in the morning. If this is still confusing, you can come back to me and we can deal with these questions. Okay, so using the Python bindings is actually quite straightforward. All you do is you open up your favorite Python method of working, whether it's a notebook or the IPython interpreter, or you write your own scripts and you say import Psrchive. And if you've used Python before, you know you can also give it a little nice name to remember it by. You can say import Psrchive as my fancy pony, if you like that, or my fancy turtle. And the next time, and when you want to access the functions, you say my fancy turtle dot function name, and then supply the variables you want to. It does its processing or does its function, and returns you the object you want. So there's three main classes which are the ones I've used personally. I'm sure there are more functions, but one of the problems with the Python bindings aspect is, or Python bindings for Psrchive, is the documentation is lagging behind in the code development. The code base is a lot larger than has been currently documented. There are very active efforts going on to fix this, but it'll take a little while to catch up. So there's the archive class, where if you want to read in a single integration, you do archive.getIntegration, and then isub is within each integration you get a sub-integration. And you can also do NumPy style addressing, where the archive is an array-like object, and then you can index it directly with the isub number. So that's what the second method is about. You can also use the integration class, which will retrieve the profile. And if you wanted to simply get just the profile, so the 1D rotational phase versus intensity, whether it's Stokes I, QU, or V, you can use the profile.get amps, where amps is amplitudes, and that comes out simply as a NumPy array, which then you can play around with. If you wanted to get all of the data, so basically read in the entire archive and deal with it as we've been dealing with it in the morning, you could do archive.getData, and that basically reads in your entire data cube, and then you can do your processing the way you feel like. Okay, a few things to remember. When you do profile.getAmps, it's a view on the original data, where view is the Python word for you are working with the original data, so any modifications get carried over into the data. When you do archive.getData, it's more like Psrchive. It reads everything into memory, you manipulate the object in memory. This is distinct from your original array. And you can save things with archive.unload. There are a few more common functions. Again, ddisperse is something I've used. Remove baseline, fscrunch, tscrunch, and there are a few other functions. Actually, there are several other functions. Again, as I said, the documentation is not really up to great speed. And this is the last thing is not something I've used personally, which is execute. But again, give it a try. It's it's there. You can try out some of the PSR shell commands. If I'm going too fast, if I'm boring you to death. Okay, no response. That's fine. Okay. You'll find more documentation on the Psrchive website, and of course, opening up the Python interpreter and doing import Psrchive, Psrchive dot tab will reveal some functions to you, and you can explore things this way. Yeah, I think I've already mentioned this, but I think the only thing extra on this slide is probably that this is one example of actually an equivalent of one of the Python of one of the Psrchive programs, which is the profile shift fit. You can use this for doing template matching, but then it's much easier to talk to Tim and get pulse portraiture running and then doing timing that way. At least that's my personal experience. So especially if you are concerned with being able to do a quality assessment for your TOAs, because this is something I haven't tested, but Paul Demarest and Maciek Cerylak, so Paul Demarest, VLA, and Maciek at Meerkat, or Sarau, are two people leading this activity. Nate, you're involved as well? To some extent.
To some extent.
So, but if you don't want to write to them directly, you can always raise a ticket at the Psrchive site. I mean, the only ticket I've ever raised is a very stupid ticket, which is I asked for a function to be added, knowing fully well that it had been added 3 years ago, because I wanted an example to be put up in the public documentation instead of just having my own script. And Paul did it. So raise a ticket if you have a question. People will try to answer those questions, and more often than not, it's helpful to a lot of other people. Okay, we can leave out the more advanced Psrchive classes, and that's the end of my slides. So the idea that I had was that I don't want to, I can see some of the eyes going. So I don't want to kill you guys yet. No, never. Come on, I love you guys. Yeah. So the example that I wanted to run through was the very standard example on the Psrchive webpage. So if you Google for Psrchive Python binding, you will find an example where all you have to do is you import an archive and you could make a plot with it. The reason I'm happy to just leave it here is because, as I said, I realize there's a lot of information coming your way. And the Psrchive Python bindings is a hugely powerful tool, but I don't see it being greatly beneficial to bombard you with advanced tricks you can try, which would all be Python tricks instead of just being Psrchive stuff, because eventually that's just as simple as Psrchive.function name, give me the data, I will manipulate it my way in Python. So if everyone's done downloading or pulling the Docker containers, and no, I see several no's. Okay, so we can take a little bit of a breather. I also did rush you through 15 slides. Questions, queries, worries, concerns?
Yep.
Yes.
So this is like a dumb question, but when I take observations and I get files, I get FITS files.
Yes.
Not archive files or RF files. So I can't use Psrchive on that. How do I go between FITS files and archive files?
Oh.
Or is there a way to do that?
Yes.
Yeah, you can do that with PAL.
Yeah.
Well, at first, it's just a matter of extension name at one level.
Yeah.
Oh yeah.
If you're taking folded archive data and it's coming off the back end in this format, it doesn't matter what the extension
Yeah.
Oh.
Psrchive should still be able to read it.
Okay.
And then
sort of convention.
yeah, like in the
So
nanograph standard kind of way, you would take a series of observation files and then use PSRadd to add them together, and then you would we never get an AR file to start with. We start doing the things to the PSR added FITS files, and get outputs. You get a calibrated file out, and then you zap it and scrunch it and do all the things.
Yeah.
Those are the steps that get taken.
Also, just so that it's clear, the .ar extension is meaningless. It's just stands for archive. You can take any input format and convert it to PSR fits. I prefer to work with PSR fits because I tend to remember the header keywords better, but you can use anything from Arecibo, you can use stuff from Westerberg, which are unique formats, but then you'll have to refer to the keywords for the headers. You have to know how to access things or how to read in files if you had to do it with something else. But I don't think it's so much of a challenge to take most common Pulsar formats and convert them to PSR fits either.
Yeah, and Psrchive, when it's compiled, it has a list of backends, it has a list of equipment that has been installed at telescopes that it knows about and understands. So I think it's even called like backends.list in the source directory. There is like a place, and I think there's a way to print out what it knows about also, but I can't remember off the top of my head what that is.
You can do psarchive info.
Yeah.
psarchive_info.
Um,
Try that.
So that lets you know like what sort of data you can work with that particular installation. And there are ways to add other types of things, but you have to recompile everything from source yourself.
I think that's yeah.
Yeah.
So those are the things the one in the Docker container already knows about. And if you want to add something to this, ask Nick, or write to Willem, or raise a ticket with the Psrchive. If it's an instrument which has a unique packaging structure, then but it's not that difficult. Any other questions, concerns while we wait for Docker pulls to complete?
So I think again, if you've managed to pull your Docker, just turn off your Wi-Fi on your laptop.
Yeah, it's.
And if you haven't finished pulling it but you want to get started, I can manually fix your container for you to at least get through this.
You can show them.
Yeah,
because the
whatever.
commands.
Or you can try it yourself.
Yeah. Yeah, those are the commands, right?
Yeah, it's that one right there.
So
Yep.
I think just judging by the speed with which my Docker's coming down, it's going to be a while. So it might be just, and maybe just go through this quite slowly.
Yeah.
So that
So
everybody
it's just
can.
one command.
Yeah. Do you want me to try to explain it?
All right, more instructions from this end.
All right, just one brief thing then. So because the Docker is taking a long time to download, and honestly, I'm not making you all pull a new container just because of this. There are other things. But if you're, two things to note, which may not have been mentioned. The Python bindings are only installed for Python 2, not Python 3. So if you're running it in a Jupyter notebook, it needs to be a Python 2 Jupyter notebook. That needs to be the kernel. So when you make a new notebook, it needs to be a Python 2 one. Or from the menu, you can make sure you choose a Python 2 kernel. So that's one thing to note. Second thing to note, if you're in this Jovian shell like this, and you're going to run IPython, first you need to run source, the word source, S-O-U-R-C-E, if I can spell right. It looks like that looks weird, but maybe that's right, source. That's right, okay. All right, thanks, cool. All right, so you need to say like source, activate, I apologize for my terrible handwriting, Python 2. So you need to tell it that you want to use Python 2 because Python 3 is the default in the container. So that's the second thing. So you either need to make sure you're using a Python 2, IPython notebook, or if you're in the terminal, you have to source activate Python 2. And you'll know because to the left side of your prompt here, it will say Python 2, right? So it'll tell you which Python environment you're using, so you'll know. That's awesome. If you run Python and you say import Psrchive and it gives you an error, that's because it can't find the Psrchive bindings because I installed them incorrectly. So even as experienced people screw up. So never feel bad. All right, so this command right here, this long string, tab completion will help you get here. But there are a whole bunch of things in opt pulsar lib python 2.7 site packages. You need to copy all of them to opt conda ends python 2 lib python 2.7 site packages. Again, tab completing these things will help you, so you don't have to type it all out. But if you do that, and you do these other things, then it will work. And if none of that made sense or you need help, just wave at me, and I will help you do it. Yeah, if you just run, if you get yourself into the Python 2 environment and you run Python, just run Python at the command line and say import Psrchive. If nothing happens, it works. If it doesn't yell at you or say anything bad, then you've been successful. But if you're not successful, then try this, and if this seems weird, I can help you do it. So, all right. You can just do things from here. If you have the data, you just copy the data file.
Alright, so a little bit of advanced instruction. The way you can test whether the Python bindings are working in your container is to open up an IPython shell.
If you're doing the same thing I am,
Just type IPython, start it up, and then type import space Psrchive. If the bindings have been installed properly, you will.
Yeah, you do.
If they work, then you will get nothing, as in there won't be any error message. If they haven't worked, then you will get a lot of errors. Right?
Yeah. So. Yeah. All right. So. IPTA 2019, like all the at IPTA 2.
So I tried to copy all this stuff, but something said I permission denied, so I'm trying to just check anyway to see if I have this right.
So now you make a directory just like whatever you want. And then data one dot
advertise that it is available now.
oh no, it's part capital part.
Okay, folks, technically it is time for the coffee break now, so there is coffee, tea, and stuff out there. But our suggestion is that if you need help getting Docker sorted out,
Oh yes.
just stick around for a bit. Those who have it sorted can go grab theirs first, and we'll try to get everyone through as as time goes by. So if you would like coffee or tea now, go ahead. Yeah. Try injecting this one.
Yes, to put this one in, and I know that because I've been exactly the same thing, and I thought target value something, maybe it's creating in their messaging code. Maybe I'm just really stupid and I can't identify it. Actually, it's none.
None of the above.
You might have
But that's not necessary. Yeah, there's like another way to reject all devices. So I need a regular company, but either way, I'll think actually.
For every lecture I did on we'll probably need those 2 live
The two big ones.
It doesn't work.
Yeah. I will circle that.
Nobody has started.
I'm running it right now. Okay. In that the password. Okay. Can I get in for 1 second?
What's the question? I don't know if I can help.
It's the same specific process.
You will do the doctor recommendation thing that you've seen with like all the work. Right.
Let me get over there and I'll try and give you the full code name.
Oh wait, maybe it's the
Oh yeah, don't have to.
that's where I put mine, but that's where I use it. That's the pathway I use to get all of it.
It just, or it did finish.
Keep tracking.
Space after December.
Yeah, the space and then search. A plus RWX add A right next to all.
Oh yeah.
Okay, try adding at the end of
Like Garver rhymes and dash dash main and then they go like have to share. If I have to share, that's in my house.
Okay, so
That's right. Which one is it?
So it's very generic. You should be able to
spit out an arrow like this. That's the thing.
Oh, it's my share.
yeah, from where you are right now. Dr.
Oh, you get the progress of your download? Yeah. I think I got it.
And so for you, just do the flash web.
Put that in the background.
I think the other one is
Control D. Your name. Check it up. Backspace. You know, like the colon.
It won't type.
And instead of wait to you try SFTC. Go ahead and search here. And then
And then so what's yeah.
Try this with IPTA with W.
I'll be with you guys in a second. I got that. Wonderful. Thank you. Okay.
Doctor question.
I always do the same error. It's the same exchange. Connection with person. I get it whenever I transfer.
Yeah, so just start. You can copy. Does that not work?
That's something weird. I feel like that's something weird happening on the other end. Like, it's like it's brilliant in some ways. This thing where it's like this bad game, like there's a copy server that you can set up, and then it's choking or something. Because I know other people who didn't have it, like I didn't.
I knew I was missing
And
something.
this is not what it did.
I'll just like for a doctor. Yeah.
Yeah. So then I can send it to DBS and maybe Alright, wait, yeah. Wait, so you think the Docker right now? I can't get the Docker
This is the error I get on Docker, whether or not it's sudo again. Right? Yeah, like it pulls for a while and then it stops.
Okay, so with
Flash drives.
I hope the list is full. Excuse me.
Okay, there's another instructor announcement. Please pay attention.
But it's non-scientific. So I hope the list is full for traveling to GMIT this weekend. If so, then I'm going to go and give it to the person who will take care of the class.
Yeah, I just /Psrchive/lib Python 2.7 site packages. Site packages.
Oh yeah.
Okay, yeah. So,
Do you have any of the data on source? Yeah, that should be okay. Just you can just use that.
Yeah, I'm sure there's
I'm gonna come around.
Yeah. I got the main things. As long as they seem to just want us to be towards the end of the
It's fine. It's fine.
easier than
Everyone,
getting
so
everything.
I think
Even on my tag, but that's very
I updated the phone and I was trying to do
Yes.
Yes.
But yeah, so I'm like, I'm a second.
these two are created, but I
Yeah, that was like everything.
I would suggest
when you're waiting for the bus.
I'm not used to
Yeah, okay, so those of you who decided to forego the lifeblood of astronomy and leave out of the coffee outside, the example I want you to run, oh, the face you make, you can get yourself coffee. I'm just going to pull up the web page and leave it at that. The example I want to run is really the most basic example for Python bindings. It's just reading in an archive and plotting it. You can either do it when your Docker pull is finished, or you can do it tomorrow, day after, doesn't matter. We could, in principle, try to make TOAs with the Python bindings. That's another example which is right on top of the example I want you to run. But again, no pressure. I realize it's 4. There's only so much the human brain can take in at a time. So, yep. I'm going to go here and say source forge. Just a minute.
And this is just a path to the folder that has the data.
Yeah, whatever. I would just make it this IPTA function. That folder that are just part of this place.
It's stored in IPTA.
Yeah, but it's working. I didn't know. It needs to, it's just the ordering is wrong. So, correct. You're pulling that. Yeah.
I never thought I'd get this far.
there are two problems in there. As in, when you run those commands, you may get complaints, because if you look at those numbers, you may realize something. But I'll leave it up to you to discover it. Sorry? Oh well, this is going to be the. You can drink your coffee. You can try this out, or you can copy down the path to the manual, and then you can run this later on. Psrchive.sourceforge.net. Yeah. Yes. So that's the, and if you go right to the bottom of the page, this is where the example is, and that the plot is only tiny bit of the plot is showing. But that's what I want to do in this session. And then I'll leave it to you to discover all the magic of Psrchive Python bindings. And then we can, if people want to, we can try more stuff day after or whenever we have more time. Yeah.
What does base crunch to end
So phase is measured in bins. So base crunch is bins crunch to number of bins 256. So in this example, the file that Willem or Paul used, that would have had maybe 1024 phase bins, and then they're scrunching it down to 256, which is why
resampling?
you call it resampling, but it's more like averaging.
And I'm gonna also look at your. I'm gonna send.
That's all we want to do.
If you have the newest, so remove the newest thing, then you won't need it. So if you just, well, you can find out. So do you source actively by Python? And then do Python. Right here, and then import. Okay, so go to import. IPython. So this is just a test. IPython, you can like is interactive, so you can do like multi-line things and go back and attack completion modes or something like that. Yeah, so it's a little bit more robust instead of just that's like you have to be exact. You can't go back. I'm gonna bring my GEOs.
Yeah, right. They just need it.
Okay.
Did you get the path? Yeah. Right. MSK is working? Still doesn't work for you?
Yeah.
Right here? No, let me try to do that. Right. So, here, you don't need the very first command.
But I mean, I want to. And you copy. Oh,
Yeah, yeah.
So whenever you're not one of the reasons.
Yeah.
So you have to do that to copy. No, in this document, you just put the code when you upload the new document. The network is just so stuck.
Yeah, it's still not. No, it's still working. Copy is still running.
No. So, and in this copy,
Oh, this copy I
that
did.
slash over to. Have you guys got this? So don't, if it hasn't finished downloading, just do what Nate's had up on the screen.
CP has to be sudo or?
Well, I should say this. I've done it on some where it doesn't matter. And I don't understand it.
Is PS Archive working?
I removed the previous docker before I downloaded the new one, so I'm still.
No, but you should. You didn't delete it. You can start the document again. You could just run it. So you should go to that document run commands and hit E.
Can you try running the document again?
Okay, now it's working.
Okay, import PS Archive is working.
Sudo source activate Python, then
Yeah.
Python and case.
Yeah. So the example I want you to run, you can find it on psarchive dot well psarchive.sourceforge.net/manuals/python. Scroll right down to the bottom of the page, and you'll find the example that I want you to run. It's really straightforward. All you have to do is read the file in and then plot it. You can try copy pasting the commands if you can't get it to work, but
On the source forge page,
psarchive.sourceforge.net/manuals/python. Yep.
So we have to type it one by one.
What?
Import file, import.
It's up to you how you do it. I'm not going to be a school teacher and force you to type it in word character by character.